All right, so this is your 4.1 learning journal. Your 4.1 journal says your I can statement is I can solve systems of equations graphically with and without technology and identify the type of solution. So the first thing that we're going to do is take our paper and we're going to fold it in half like a booklet. And this lesson was all about graphing. So we're going to look at each graph and identify the number of solutions for each graph. So we notice in our first graph, we have one solution. This is called consistent, independent, And notice that the slopes are different. Notice here the slopes are different. My solution is that point where the two lines intersect. Our next example, I have two parallel lines. This means that there is no solution because the lines are parallel. This is inconsistent. This is an inconsistent. And notice that the slopes are the same. The slopes are the same. And then our last one, I try to always use two different colors when I look at this last one because it can kind of be deceiving. But I have a line that I'm highlighting in blue or drawing in blue. And then I have one that I am drawing in red. But I'm drawing them right over the top of each other because this has infinitely many solutions. And this is called consistent, dependent. Okay, consistent, dependent. So now let's go ahead and look at our two examples. So example number 1, we are graphing. So our first equation, y equals 4x plus 1. Well, both of these are actually written in slope-intercept form for us. So I'm going to identify my slope and my y-intercept. Remember that my y-intercept is where I begin on the y-axis. So I'm going to begin at positive 1. And then I'm going to count up 1, 2, 3, 4 over 1. Or I could count down 1, 2, 3, 4 into the left one. So my first line looks something like this. For my second equation, it is also written in slope-intercept form. So when I identify my slope, m equals 1, same thing as 1 over 1, and my y-intercept, b, is at negative 2. So here I'm going to begin at negative 2. I'm going to go up 1 over 1, up 1 over 1. I can also go down 1 and to the left 1. And hopefully you see that when you do that, go down 1 to the left 1. Your solution, the place where both of these intersect, is the ordered pair negative 1, negative 3. Now remember, every time you solve a system, you need to check your solutions. So equation number 1, y equals 4x plus 1. Y is negative 3 equals 4 times negative 1 plus 1. Negative 3 equals negative 4 plus 1. negative 3 equals negative 3. So this solution works for the first equation. Let's check equation number 2. Equation number 2 is y equals the x minus 2. Remember my solution, y is negative 3, x is negative 1, minus 2. Negative 3 equals, let's see, negative 1 minus 2 is negative 3, so this works for both. Works for both of them. All right, our next example, neither one of these are written in y equals mx plus b, slope-intercept form, or standard form. So I'm going to have to take both of these equations and manipulate them. So for this first equation, I am going to solve for y. Solve for y. So I have negative 2x minus y equals 1. I'm going to add 2x to both sides. Negative y equals 2x plus 1. Now for 2 days, we have solved for y, and we've had instances that have led us to have a negative y. And both times we've had to divide every single term by negative 1 or multiply every single term by negative 1. And that lets me have y equals negative 2x minus 1. My slope, negative 2 over 1, and my y-intercept at negative 1. So I'm going to begin at negative 1, and then I'm going to go down 2 and to the right 1, down 2 and to the right 1. Or I could go up 2 and to the left 1, up 2 and to the left 1. So when I connect my lines, I get this beautiful graph just like that. Connect my points, there's my graph. So for my second equation, negative 6x equals 3y plus 3. I'm also going to take this equation and I'm going to solve it for y. And I'm going to do that right down here. I'm going to solve it for y. So negative 6x equals 3y plus 3. I'm going to subtract 3 from both sides first. Negative 6x minus 3 equals 3y. And then I'm going to divide everything by 3. Negative 2x minus 1 equals y. So I notice that my slope is negative 2 over 1, and my y-intercept is negative 1. So when I plot these points, I begin at negative 1, and then I go down 2 over 1. And hopefully you see that both of your lines are stacked right on top of each other. Both of your lines are stacked right on top of each other. So this is an example of a system that produces infinitely many solutions. Infinitely many solutions. So this is your 4.1 journal. I want you to make sure that you glue that into your journal. Glue it into your journal. I don't want to have to go through someone's backpack and help them find the last 4 journals so they can complete their test. Glue this into your journal and then come back and we'll start the next journal.